I've been doing Python for 8 years, and here are 4 more mistakes that every Python beginner does and how to fix them. So let's go. So number 7 is when you're working with dictionaries, overwriting values in dictionaries instead of incrementing. So let's say I'll show you real quick, which is when you have a dictionary, sometimes you want to increment a value. So here, if I have a new category is random stuff, okay? So this is our new category of payments that goes up here. So if I do new category random stuff and I go through the categories, and if I say if for expense, or let's say I write to the expenses, and so I write expenses, new category is 120. So you'll put 120 into a new category. But let's say that this new category, so if I write this and then I can print the expenses here, so you can see them all. So here you see all of the expenses and I've added random stuff. But let's say that I write this random. And so what I'm trying to do here is every time that I go in, I want to add to the expenses, right? But if I do here random, the random key already exists. And so if I do this, even though I wanted to increment this, which would be adding 120, if I do this, this is an equation. So it's going to overwrite the value. So now it's going to be 120 and it's overwritten the value. It's overwritten the value instead of adding to it. And so this is the bad way to do it, which is not checking if value already exists. So what you do when you use dictionaries is that you want to use the good way of doing it, which is you want to check if some of these keys already exists, because you don't want to overwrite them. So what you might write is something like the following, which is, let's say your new category was random here, but you want to do these checks where you say if new category is already in expenses, which means, hey, this already exists, then what you can do is that you can add to it. So here you see it in the suggested code, but if I write expenses, new category, if it already exists, what I'll do is I'll plus equals an amount, like 120. But if it already exists, I can write else. So this is if it already exists. And if it doesn't exist, then I do equals. So I do equals 120. And what this means is that now, if I run this, instead of replacing this with 120 like it did here, it'll check if a random already exists and add 120. But if it doesn't exist, then it will just set it from scratch. So here, I'll just print expenses again. And you can see it's added 120 here. I ran this before without printing. So if I do 360 plus another 120, it'll be 480. And there you see it. Whereas if I do something like random 123, it'll be adding this random 123 here and setting it from scratch. So that's how you make sure that you update dictionaries properly. Now for number 8, what we're going to do is what we're going to do for number 8 is accepting negative numbers. So it's not properly validating. So what might happen is that your user might, for example, the bad way of doing it is that your user, you might ask from your user like an amount. So let's say amount equals input amount spent, right? And and then you'll do something like, and we can do this float function to convert it, right? So you've done all the good things from last time, but then if you print this amount, right? Amount here is my money. And we can do that F format thing that we showed you before. So I can write this, but someone can try to hack some of it, right? So I can start to do minus 100. And it says your money is minus 100, which typically isn't possible in some debit accounts, right? And so you want to start validating this input, right, with rules apart from types. And so a better way that you can start adding user input validation, which will help the security of your application, is actually checking this stuff, right? So I can write a function called define check validate number. And so here, if I do number, I might do if number. So I might do try if float number greater than 0 or less than equal to 0, less than 0, we're going to print raise value error, negative numbers not allowed. And then we can, for example, here return float number if everything is fine. But we can also here accept value error. And then you say, please enter a valid number. So if we run this and we copy this code and we put it here, we can, for example, write here validate number instead of the float function. So if we run this and we write -10, it'll say please enter a valid number, and that's how you ensure that that it's not running it's not causing any errors. And so we could wrap this all together so that, for example, if it raises that error, so you can also raise it here, that it doesn't cause any issues. So we could, for example, here make it so that it's only if amount it'll run this. So if I do -100, there you go. It says please enter a valid number. So that was number 8. Now we'll jump into number 9, which is that you want to have clear variable naming. And this is super important because let's say I start off by writing A equals 100, B equals 200, and then I do print my value, and then you write C underscore garg equals 300. What happens is that, like, I might start writing this code and it makes total sense on a logical level, but then someone comes and reads this and is like, what the hell? It basically makes it so the code is not well maintained. And it might even, like, you might know it in one instance and come back to it next week and have no idea what this means. And so you want to start employing good and proper naming conventions, whether that's for your functions or your variables. So I might here write salary in, and you can put the underscore and you say 100, and then you can say benefits equals 200, and then you can say other income equals 300. And then when you print this out, you start to really understand what this means, right? And if you even want to simplify it, you can start to think of variables as even just language for you to communicate some of this, right? So if I do total equals all of this, not only do I benefit from this code being a lot cleaner, but someone else can understand why I summed these all up. And it's because I wrote something like income total. And so it's much easier for someone to understand. So really start to think of your code as that you're coding for others and not just yourself, and you're coding for understanding and not just logic. So number 9 is clear variable naming. And number 10, what I would recommend is too long of functions. So really you want to keep your functions very tight if you can. So the bad way of doing it here might be that I might write something like define total all numbers. And so what I might do is I could take in a ton of different numbers like A, B, C, D, E, F, G, H. And let's say that we, for example, do total income equals A plus B plus C. And then total cost equals D plus, you sum all of these up and you say something like return profits equal the total income minus the total cost. And then you make another function which says the cost efficiency is the total, the profits over the total cost. And so you might say total cost efficiency. And then you return, for example, the total. And the total might be A plus B plus C plus D. And you might return the profits. But what might happen here is that, like here, if we do total cost efficiency profits, you can see that I'm doing a ton of different things here, right? So here, if I do 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So if I run this, I get minus 24. But as you can see, this starts to be really confusing because I'm writing one figure here that's not even being used, etc. The much cleaner way would be to break this down, and you want to keep the scope as tight as possible of your functions. So the better way of doing this is, instead of doing tons of things at one time, break it down into individual functions and try to say that one function does one thing. So for example, I might copy all of the code that we wrote here, and I'll make these into different functions. So I'll start off by saying define total income is A, B, C, D like this. Then I might define total cost and I might return this. And then I might define profits. And then you might define cost efficiency. And what this means is that you can start to reuse this a lot more. So I can return this, but I can take these in as inputs. And I can start to define these way more, because I can say something like income is total income. cost equals total cost, and then you can print the cost efficiency and look at the profits. So I might say profits is profits. And there you go. You get the same figures. And so here, for example, I can print profit. But it's much cleaner because you can reuse these. It's not confusing logic and people can understand it way better. So here were different mistakes and errors, most common ones that I see beginners make. We learned that in dictionaries that you have to check if a value exists so you don't overwrite it. So you know when to add instead of overwriting. You learned to be careful with conditionals when you're getting inputs from users. If there's logic that you should adjust so they can't like hack you, for example. You learned about clear variable naming so that you're coding for others and understandability apart from logic. And you also learned to keep your functions small and focused so you can reuse them and understand it. Hope this helped. Please let me know what you'd like to see in future videos, and all the best on your Python.